We're going to talk about making conversions. Sometimes it's called dimensional analysis. And maybe in your career so far, maybe you've heard it described as something else. And along with that comes the idea of conversion factors. So this is a really important component of science. And so it's important that you figure out what works for you, because there's several ways to do these types of calculations. So for instance, let's start with this first one. Oh, sorry. So we got to convert 7.54 meters to centimeters, okay? So how would we do that? And I put here on the right side, you have a table kind of similar to what you see in your top hat page on units. And if we look at the prefix of centi, it's right here. And see here, we can see centi as 10 to the minus 2 centimeters, okay? So what does that mean? That means that if you put centi in front of the word meter, a centimeter is equal to 10 to the minus 2 meters, okay? So how many centimeters are in a meter? So again, if it's 10 to the minus 2, sorry, so centi means it's 10 to the minus 2 meters. It is 0.01 meters. It is less than a meter. A centimeter is small and a meter is large, okay? So several centimeters fit into 1 meter. And that's what we're seeing here, okay? And these here are conversion factors. That's what we call them, okay? And they come from what's called an equality. And the equality is that 1 meter equals 100 centimeters. And I really want to emphasize that this is just one way to think about this. People have different ways of thinking of these, okay? So for instance, we saw on the previous page that it was 10 to the minus 2. So that means, and honestly, this way is a little bit confusing for me, but that it's 10 to the minus 2 meters in 1 centimeter. This way is confusing for me. I know some people like to think of it that way. I'm not going to talk about that in this video. If you want to talk about it more, we can talk about it in office hours. But another way to think about this is that 1 meter is equal to 10 to the 2 centimeters. This equality that I just wrote, that one makes sense to me. I can work with that one pretty easily. It looks really similar to the first one I wrote. 1 meter equals 100 centimeters, or 1 meter is equal to 10 to the 2 centimeters, okay? So again, these conversion factors here came from this equality. Whenever you have an equality like that, then you can write they look like fractions, but they're called conversion factors. So from this equality, we can also write another conversion factor. So we can also write conversion factors from this equality, okay? So we can write, there are 10 squared centimeters in 1 meter, or in 1 meter, there is 10 squared centimeters, okay? So this is one of the hardest parts, I think, for students to realize, is that they can use something like an equality with the equal sign, like 1 meter equals 100 centimeters, or one of these, and they can turn it into a fraction, right? Like these in the circles, and they can have it, whichever way is going to work for the calculation. So let's look at what that calculation looks like, and let's see what I'm talking about. Okay, so here we're going to convert 7.54 meters to centimeters, okay? Now let's say we don't know which one to use. If we use the first one, we end up with centimeters on the top and meters on the bottom, and our meters cancel out. As you can see here, meters cancel out. And when we multiply the top number, 7.54 times 100 gives us 754. And our units are left with centimeters, okay? Now, if we use the second conversion factor, if we use this one, then we end up with 7.54 meters times 1 meter over 100 centimeters. This time, when we do our units, we get a meter times a meter equals a meter squared over a centimeter, okay? And 7.54 times 1 divided by 100 gives us 0.0754, okay? So in the second scenario, we end up with these units of meters squared over centimeters. They're meaningless. They don't make any sense, okay? Where in the first situation, we ended up with centimeters, which was our original goal. That's what we were trying to get, okay? So by paying attention to units, I'm sure previous teachers have emphasized the importance to units to you, and I just want to reiterate that here, is that if you pay attention to the units, this is a way to double check your work, you know, to make sure that your units cancel by putting in the conversion factor you need to make sure, and usually it's whatever you're getting rid of, in this case the meter goes on the bottom, and whatever your target is goes on top, okay? And we'll see in a little bit, sometimes you got to use more than one conversion factor, and that gets a little bit more, you got to think it out a little bit more. So let's look at another example. This is converting 454 kilometers into miles, okay? So again, if we think about what we just saw from the previous slide, we have kilometers, we're trying to get rid of them, so that goes on the bottom, okay? And miles is going to go on the top, because again, that's what the question's asking for. We want to make it into miles, so miles is going on the top. And without putting in any numbers, we can see when we do this, we get kilometers times miles divided by kilometers. So kilometers cancel out, and you're left with miles. Here's a conversion factor. There is, for every 1 mile, there's 1.61 kilometers. So that's our conversion factor. We plug it in. Carry out the math. Again, we multiply all the top numbers and divide by each bottom number, okay? So that's 454 times 1 divided by 1.61, and you get 282 miles, okay? All right, let's look at this example, okay? So if we had to convert 3.75 times 10 to the third megabytes to nanobytes, okay? So again, we want to, if you set up your units first, put the unit you're trying to get rid of on the bottom, and then the unit that you are going for on the top, okay? Oh, and an N is missing there. Oh, so in this case, this is a good example. So maybe it's too confusing to go straight from megabytes to nanobytes, okay? If we go back, well, we won't go back. And so this first conversion factor here will help us convert to bytes. And then the second conversion factor here will help us convert to nanobytes, okay? And so if we just look at what happened to the units there, megabytes will cancel out with the first conversion factor. And then when we multiply that by the second one, it will cancel out the bytes. And we're left with the units we're after, which is just nanobytes. So we put in those conversion factors again from our table. Notice this is being done a little bit different, right? Instead of writing out a million, they're just using 10 to the 6, okay? And that's fine. That makes it easier to do. And again, instead of writing out for nanobytes that, you know, that it's a billion, they just wrote 10 to the 9th, okay? So if you carry out this function, and you've got to make sure that you can plug these into your calculator, okay? It's 3.75 times 10 to the 3rd times 10 to the 6th times 10 to the 9th, okay? You can get 3.75 times 10 to the 18th, okay? One way you can do this, and I'm sure it's been a while, but if you guys remember with exponents, when you're multiplying them, they add up the exponents, okay? So here we have 3 plus 6 plus 9. That is 3 plus 6 is 9, 9 plus 9 is 18, and we get up with 18. So that's a good habit to get into to just kind of estimate what your answer should be. If you had gotten something like 17, 18, or 19, I would say, okay, we're in the ballpark, because sometimes it can go up a little or down a little depending on the numbers you're multiplying, okay? Remember, when you're dividing exponents, if you had ended up with like 10 to the 6th on the bottom or something, or the 10 to the 9th on the bottom, then you subtract exponents. So that's kind of a quick way to kind of estimate what your answer should be around. And you can see scientific notation is more useful here than writing out the whole 3.75 times 10 to the 18 nanobytes. Another thing I really want you guys to be cautious with is when you're using multiple conversion factors like this, is that you got to take, in this case, it was just 1 in the denominator, so it doesn't really have an effect because we're just dividing by 1. But if there was different numbers in there, you would take 3.75 times 10 to the 6th, 3.75 times 10 to the 3rd times 10 to the 6th times 10 to the 9th, and then you would divide it by the first number, and then you would divide it by the second number. So this is a common place where students plug it into their calculator wrong. So make sure you're comfortable with doing these conversions.